So, what is Natively? Natively lets you generate a full mobile app in just minutes. So, for instance, if you want a moment countdown app, event countdown app, you will get an event countdown app. If you want a voice notes app, you will get a voice notes app. So any idea or description that you input into this prompt box, you will get that as a mobile app. So if you want to continue building your app, you just continue prompting and talking to the AI, to our agent, and it will continue building the app for you. And you can scan the QR code and run the app locally on your own phone, or just in the browser. So probably you have some follow-up questions to what Natively is, so I'll just go through them quickly, the answers to this. So yes, you can generate any type of mobile app, anything you want. It runs entirely in the browser, so you don't need to download any code or run anything on your own machine. We generate the backend for you as well, so if you need authentication or a database or some integration that needs some serverless function, we do that for you as well. You own all of the code that we generate for you, so you can leave the platform at any time if you wish to do so. And lastly, you can deploy to the App Store and Google Play Store if you wish to do so as well. So now that we know what Natively is and we have the context of where we are generating the app, generating the code inside of, let's get to the fun part, the code generation part. So how do we generate code fundamentally? Well, of course we can write it ourselves, but nowadays we want to use an LLM for this. So let's start here. We send a prompt to the LLM. For instance, write me the code for a meditation app. And the LLM will respond with a block of text, and some part of that text will be the actual code for the app. So we need to parse this code. Very simple. We just give the LLM more instructions to output the code in a certain format, and then we programmatically extract that code, and then we can run it for our user. So now we have a very simple, very beautiful pipeline. So what happens when we run this? What do we get out? Well, we get a not so good app. Most likely it will not fulfill the user's request. It will maybe not even build at all. And even if it builds, it might just be a very ugly looking app. So how do we fix this? Well, maybe we could instruct the LLM a little bit more about what to do, what not to do. Maybe generate a plan for it to follow. Maybe let it think a little bit before it starts generating the actual code. So let's add this. Let's process the prompt a little bit and input a better prompt into the actual LLM when it generates the code. So, and of course we want to sprinkle our own secret sauce here, like every platform is doing at this step. At every step, but especially at this step. So what do we get now? Now we actually get a fully functioning app, which is great. But it takes a lot of time to complete, and it's also inconsistent between runs. So maybe we want to give the model a starting point for a base project where it can continue to work on without it having to write everything from scratch. So let's try this. Well, now we realize we have a context size limit. Like all LLMs have a certain context size, and if we just try to push all of this project code into the LLM, then we have run out of context and it will just not work. So how do we fix this? Like this. We do a more, we run a bigger loop for the LLM where we add tool call functionality where the LLM can fetch what files it wants to read dynamically when it feels like, when it needs. So it can dynamically add the context which it needs at runtime, and then it just calls itself over and over again until it has all the context it needs. And at that point, it will generate a better app. So if we run this pipeline, we'll get an even better app. But when we let users try this, they will quickly not complain, but they will have requests that we want a backend, we want authentication, we want login, we want more integrations. Maybe the model needs to ask the user to do some action which only the user can do. So we add more and more tools tool functionality to the LLM, so it has more ability to do more stuff. And this is looking quite good. Now we're getting somewhere. But of course, the LLM can produce faulty code, so we need to add some sort of verification or quality check at the end. So we add that as well. Some quality assurance, some testing, and then at the end we can run the code, and it will probably be quite good actually. Okay, awesome. What do we get when we run this beautiful pipeline? We get a quite decent app. We get a quite decent app from this. If you manage to replicate this, you will actually be able to generate apps for yourself if you want. But now we get some users here. I'm a user, this looks great, I want to have some more functionality. Add a menu for this, add something else. And now we start to get into some real trouble. The first, generating the app from scratch, that was the easy part. Now, when we have the app, we have a big project with a lot of code, we have two major issues. First of all, the existing code is at this point we have a lot of rows of code. It's way too much to just input it to the context. But of course, the model needs to know about the code, because if it doesn't know about each part of the code, then it will start to generate the same buttons, the same components over and over again. And then the issue just becomes much bigger, it just escalates. So we need to handle that in some intelligent way. And also, for the user, we need to keep track of everything which has happened previously in the conversation. Because if the user said, well, I want a liquid glass themed app, and you just don't input that to the next run, and you generate something else, now you have an angry user which says, the model isn't listening, it's not doing what I want, it's running in loops. For instance, maybe the agent responded with, do you want me to do A, B, or C? I will proceed with B, but I can also do A and C. And then the user says, no, actually, undo what you did there and do A instead. Then you need to tell this to the next model, otherwise you will have big issues. So somehow you need to intelligently pick the right information to input into the context for the next model to write more code. How do we do this? This is a whole science, or also a little bit of an art. So just very briefly, of course we want to include the most important parts, like I just mentioned, and we want to summarize the less important parts, because they can still have an effect on the whole project. Maybe we want to include some high-level relationships of the code, how all the components interact with each other, and so on. And of course we need to let the model know that it can fetch more information if it wishes to do so. So we can solve it by just putting more stuff into the context, maybe picking a bigger context size model. But we will quickly run into latency issues, because when you stuff 400,000 tokens into Cloud Sonnet 4, it takes multiple seconds before it even starts to generating the response. So very bad UX, the user will not like this at all. They want to see continuously streaming, things happening. The output also becomes worse the more you put in, because the model has a certain amount of attention. So if you put in a lot of stuff, it will divide its attention on all of the different stuff, and it will just pick something to go with. You will not have any control of the output. And of course the cost will increase as well. So we want to keep the context a minimum for the best output when we're doing this. Of course, we can also pick different models, but again, it's a cost, quality, and speed. The trade-offs, no matter what you pick, you're gonna sacrifice something else. Like a concrete example, when GPT-5 came out, we switched our free tier users to GPT-5, and immediately we saw build errors go up for these users. It simply generates worse code than the model we used previously, but much cheaper. Okay, so how do we move forward? Well, just like Isaac Newton has his 3 laws of motion, in physics, I believe we have today's equivalent, which is Sam Altman's 3 laws of AI. Models will always become smarter. It's just a fact. Models will always become cheaper and faster, both at the same time. They're kind of equivalent. And lastly, models will always have larger context sizes. And they will be able to juggle the context. Like, they will be able to use the context that you put in better with time. And on top of this, we as developers, of course, are just becoming better and better at orchestrating the models and handling these context issues. So a year from now, I think we will be able to generate bigger apps from just one prompt. We'll go further and further. The whole backend, right now we can do it, but you need to prompt it. Like, I want login, I want this, I want that. In a year from now, we'll go much further on each prompt, and yeah, it will go faster as well and become cheaper. So yeah, thank you very much for listening. Try out Natively.dev and add me on LinkedIn. Thank you.